Hello, people. Let's let's see. We got about 4 minutes before the stream properly starts, so uh, I'll hang out until then. Um, do, do, do. Hey, Strange Zach, what's up? Um, what's up with me? I guess I should answer. Not much recently. Um, been just getting some stuff done. Working on the new 4coder engine all day. It's looking. I mean, the early part is looking very good. Like, um, I started 4coder obviously back a long time ago now. What? Like, I think it was December 2014. That seems right. And I was not as good at programming as I am now. So there's a lot of things in there that are like all messed up, including the fact that I don't have any proper testing system, and I've tried several times to add a testing system, and it worked to test like one or two things for a little while, and I never really gave it enough time to fully lock it in and be like, okay, this testing system works, and it's going to work for a while now. So that's always been kind of a problem. So the first thing I did this morning was actually, before I even worked on the engine, I figured in the new branch, the old branch is still kind of different, but in the new branch, I've reorganized a number of things to be the way they should have been, and then I decided, while I'm at it, why don't I go ahead and make a proper testing suite that does all kinds of the things that I always want my testing suites to do, and it seems to be working pretty well. And then I've gotten started on for a couple hours, the very first important thing. I'm done reorganizing stuff for the new build and actually working on the new engine, and at least like the way I'm going to change UTF-8 translation, it already looks way better, and I'm very excited about it. Which I'll discuss a little bit more when the stream starts proper. It looks like, let me catch up on the chat here. So let's see, Captain Craft is having Twitch problems, things are clicking and they're not doing anything. That sounds like par for the course. Hey, Hugh or Caleb. Hey, Andrew Johnson's in the chat. Good to see everybody. Cuber Caleb says there's a version of count lines of code in Rust that doesn't take forever to execute. That's nice. Yeah, the clock I've got is ridiculous. Like, it's gigantic amount of code, and it's just supposed to count. I don't understand how it's even real, to be honest. It doesn't make any sense. I'm going to replace it sooner or later because 4coder's got all the lines of code and it's just some metadata stuff, so I'm going to, at some point, not have to run the command. It'll just be a little thing you hit on 4coder, and it doesn't even have to measure it because it'll have kept measuring it the entire time as a background metadata, and it'll just report it to you. Because it's going to need stuff like that. It might not actually be lines of code. It might have to go through them again to figure out which ones are comments and stuff. Now that I think about it. Captain Craft says I beat him to testing. I assume you mean on your least thing you still don't have a very good test system. Yeah, I regret not starting with a test system right away in 4coder, like day one almost, because although the tests over time get written and then deleted and replaced because a new system comes in that needs to be tested in a completely different way and so on, basically anytime you change an internal API between two of your sort of layers or anything, you have to change a test if you're like doing super thorough testing. But not having a test system means that when you want to test, it's actually kind of a hassle. Like, you don't have the ability to just open up a new file of code and write a thing that tests something, right? It also is nice to keep testing all the way through because you'll be surprised how much, like in projects I've started since 4coder, which there have been a couple, I've always done testing early on. And one nice thing about doing testing early on is not only that it make sure your code is, not falling apart. It also forces you to kind of think about, okay, how many dependencies does this actual layer have, and does it actually belong in a layer? So if I want to test, say, the translation system, well, it's not actually that appropriate that that has to bring in the system pointers for allocating and all that stuff, or the font system, but that was how my code was structured because I was just lazy when I put it together and I didn't have a test that said, oh, hey, that doesn't compile because I don't have fonts. And then you stop and go, oh, right. Translation really ought not to depend on fonts because the color can easily do that step themselves after the translation, and it'll just be, it's nicer and it's more friendly when your things are less interconnected, right? So even if it doesn't really change how things get done in your actual program at all, if you ever decide to copy that code to somewhere else and you didn't get rid of systems and fonts pointers, you're gonna go, why did I do that? And that's actually something else that's made testing hard. Since I didn't start with tests, a lot of the code can't really be picked apart that way anymore. At least not without a major rewrite, which is what I'm doing now. So it was hard to do any testing without majorly changing a few organizational things. And yeah, actually, since we're on the topic of tests, why don't we dive into this a little bit? I've been thinking about tests, and I have some ideas to float with you guys, because I've been, I mean, if you read like literature on tests and stuff, it's like, oh, unit testing and regression, the word regression test, and I see Ratchet Freak has mentioned regression test, which makes a little bit more sense than sort of the unit testing philosophy, but none of them, in my opinion, none of the ones I've like read up on really feel like they actually get anything. Like, not that they're stupid people or something, but it's just like, this is just sort of ad hoc-ishness. It is not a general principle that spans across all things or many domains. It's just like, oh, here's a way I found to test this problem. For example, there's this thing about, oh, on your your rounding functions, you can just test all possible floats, right? And that's true. So that's like, for anything with a small input set, test every input. But of course, that also is a situation where you have to have the correct version. So you need to have a correct version for that test to work. And so there's a question of, can you test things without a correct version, and all these kinds of like real problems that I don't actually see people like categorizing and addressing in a formal way. And maybe it's out there, it's just I haven't found it. So Ratchet Freak says integration tests. I've heard that one, and I don't really know what that means. Like, I don't get how your code isn't perpetually integration tested. Are you not, like, how could it, is there such a thing? The reason I don't get most of the talk about testing is people seem to say things like, with integration testing, what are you making sure that it works when you put it into your whole application? But why wouldn't that have been, like, I don't know, that seems weird. How is that a test? How is that not just you having built the right thing? You know what I mean? It's unclear to me what an integration test is that's different from a regression test. Is it testing for correctness in a different axis that is like formally different in a way that you can think about, or is it more like, oh, we just sort of feel like this is different and we haven't studied it, but we're going to call this an integration test and this a regression test because they sort of feel slightly different in a certain way that we haven't really figured out. And that kind of stuff bugs me because I feel like it'd be nice to try to work out a formal thing, and I've been wondering if if there's better literature out there for it, or if the ideas in my head are just specific to the problems I'm solving, or what the deal is. Alright, so we got a couple things here. Let me make a to-do list for us to chat about things, because you guys have brought up tests, which I want to describe how I do tests a little bit, because I think it's interesting, and I have a kind of theory that maybe we'll get to. Strings, because Captain Craft is asking about my string thing earlier today. I have a nice string library that I use for a lot of string stuff, and I don't know, it hits a sweet spot for me of the exact thing I want to be able to use for strings. Maybe it's just because I've gotten used to it, though, of course. It might be that it's actually terrible and that I just got used to it, but I think it's pretty nice. Yeah, so Ratchet Freaks as an integration test is where you test the whole program instead of just a segregated part like a unit test, but that doesn't... I mean, does that just mean you run the program and see if it works, or does that mean you do record your input and play it back and see if you get the right results? And or does it mean like you make random perturbations of input and see if something crashes? Like integration test, I guess, is setting what's the goal of this test, see if the whole thing works, but that's not really a method, right? It's like this is something we wish we knew how to do, more like, right? And that's what a lot of that stuff sounds like to me, like, oh, a unit test, we'd really like to be able to test if this thing works in isolation, we just don't know what that means or how to do it in a way that is sort of portable across many problems. And then I was going to mention Mac ports if anyone's interested, and 41x progress. Put that on my to-do list. Yeah, Captain Craft, the string library has a C and a C++ mode, and I'll show you that. But I have a thing where you can say use in C mode or something like that. You define that, and then it doesn't use a few features, but then it works in C. Basically, that's just because I want to use a couple function overloads, like you'll see what I mean exactly, but I want to use a few function overloads, but you obviously can't do that in C. So if you do the one thing that's like, oh, we're in C mode, then it just suppresses a couple overloads, and you have to use the long name of those functions instead. And I'll show you what that looks like. All right, so Team R&B says that these names are just semantically different, but okay, hold on, let me finish reading what it said. But in the end, it is simply testing the program. Yeah, that's kind of my impression, that they all kind of boil down to the same thing, and you have names on them that are just roughly maybe mean something like unit test. It's not really a formal idea. It's like everyone kind of roughly agrees that a unit test is a smaller part of the program running in isolation with some extra test code, and this other kind of test is this other thing we do, right? It's sort of agreed upon language that doesn't mean some specific thing, but gives you a rough idea, and that's the best we've got, is what I can discern from things I've read. So let's see. Oh, and Cuber Caleb wants me to bundle in Unicode handling with my strings. So that, I guess, you're looking for sort of like a slight Unicode lesson, or how I approach Unicode handling at least, or something like that. We can do that. So let's see. Since we're talking about tests, I guess I'll dive into that. So I have this interesting theory that I've started to develop in my head as I've been, you know, thinking about how I test my code. And I want to float it with everybody and see if anyone's got feedback or can say, oh yeah, that's very particular to the way you write code and wouldn't be portable, or whatever the feedback would be. So basically, the first thing I started to notice, and this is something I have only a rough idea about so far, but the first thing I started to notice is different types of solutions to problems. And this isn't quite like there's like coding methodology where you've got like object-oriented programming, compression-oriented programming, and so on and so on. I'm not talking about that. I'm saying forget how you write the code and you just think about the solution you end up with. What kinds of solutions can you come up with, right? How can you think about different algorithms, basically? And it's not about how you write code. You can think about these methods or these paradigms in an abstract way, separated from writing code, and they're just sort of about lenses at how algorithms work. So here's a few of the ones, or I'll call this algorithms/programming lenses. So here's a few of the ones that I've discovered are pretty prevalent that you end up either hearing other people talk about or eventually using yourself if you like encounter the right place to use it. And I think different people will lean towards, oh, programming is really all about that one or this one, depending on the kind of problem they solve, which is actually I mean, at some point maybe I'll tell the backstory about how I came up with this idea, but it was actually someone I got into a conversation with said, "Oh, I think programming's all about this," and I said, "Well, I always think it's all about that." And after we explored it, we realized we didn't really disagree. We just different different programming problems and approaches lead you to having these different lenses about what you're doing when you program. So, one of them is sort of this idea that you mostly have sort of, what should I call them? I guess systems and interfaces, right? So the way you think about the problem is in terms of, okay, we've got this system over here that can do X, Y, and Z. We've got this system over here that can do A, B, and D, or A, B, and C, and we need to expose those in such a way that they can talk to each other and get all of the information back and forth correctly, right? And I think this one sounds most like object-oriented programming, but I'm actually thinking of things that aren't to do with how you write the code, like I said. So this is like when you sit down to program and you have a couple of devices. So you have an internet thing coming in, you've got a screen and a controller, and you're thinking, all right, and then you have the CPU, and you've got these different devices. Each of them has a set of capabilities, right? The controller can record some information, and it has an interface to send that to the computer. The monitor can display some information, and it has an interface to accept that information it should display. The internet cable can do both, sending information in and reading stuff back, and it has an interface. And so some programmers are all about these systems and interfaces and how they get them to work together, right, into a big application. Then there's the sort of like data conversion, right? Every problem is a data conversion thing. This is like, if you're talking about methodologies, this is like data-oriented programming, right? Every problem is, I've got some data format, I've got some related data format, but they're different, and I need to convert between them. Or I've got like user input data and texture data and mesh data, and I need to update a game state and then render to the screen. And so there's just these 5 different like data types that I'm manipulating, and like the game state's mutable, and everything else is either a read or a write buffer that I'm just dealing with. And so it's all conversion problems for the most part, right? Then there's also like compression, data compression / expansion solutions to things. And this isn't like compression-oriented programming like the methodology. Here what I'm talking about is like, you look at a problem and you go, okay, we have, for instance, let me talk about my Lexer, because this is where I got the compression expansion idea. The Lexer uses a lookup table to avoid having to do lots of branching, right? So instead of switching on which character type it sees and then going into a state and then doing some special additional switches to figure out more stuff, like, oh, I saw, for instance, I saw an equal sign, and then go to a state and see, hey, is there another equal sign after this? And then, oh, there is. Okay, then emit this token, otherwise emit that token, and change where my next position is depending on what I saw there. Right, lots of switches and stuff. That's writing that out as a big tree of ifs. Writing that out as a long tree of ifs and switches and things is sort of a very compressed way to represent the problem of lexing, compared to writing a giant lookup table that for each character you look at a certain column of the table, and then for whatever state you're in, you look at a row, and that gives you another state, and then that continues until you hit a state that says, oh, emit the token equals, right? And then you run it again from scratch, and you find out, oh, emit the token identifier, right? That big table is just a very big way to represent that, especially when you include that your table also needs to have, like, oh, string prefixes, integer, sort of integer postfixes or suffixes, preprocessor stuff, keywords, and so on. It's a gigantic table. And so what you could do is use the very compressed thing, which is the tree of like the heavily branched switches and ifs in a big old like state tree where you send to the bottom and then switch back up to the top for the next one. You could decompress that all the way to a gigantic table that contains the entire C language, and that's huge, but that's too much memory. It would be a little faster, or quite a bit faster, but it's too big. But then there's kind of like, okay, we want to figure out exactly how big the data should be for our solution, and so we're going to expand the solution a little bit, but we're not going to expand it to the huge table. We're going to compress the huge table into a few subtables, and we're only going to use one of the subtables when we get to, oh, we see that this is an integer, okay, then go to the integer suffix table, right? So all of that's like, it's not about the actual data compression as in like we're going to sit down and do compression, although that's probably the way that people who do compression think about things probably think about this a lot, but I'm assuming. But like I've found that a lot of times I'll have a thing where, okay, I've got a 4-byte thing coming into me, and that 4-byte thing has a bunch of flags, and then I expand that out into like a 32-byte thing that more expressively describes the same information, but in a way that's easier to use. And then when I'm done, maybe I compress that back down to a 4-byte thing. So that's sort of the idea of, and yeah, Enemy Mouse has the right idea that you have sort of a little bit of a mix of, you have a state tree where you're going down branches, and you try to minimize the number of branches, but you're also letting the table be as small as you can so that you don't have like a bunch of cache misses, which kind of defeats the purpose and takes up a bunch of space. Right, so that's another way that you sometimes think about a problem is, oh, I have to rewrite my data in a way that's more expressive than what I had before, or I need a smaller version of this data so that I'm in cache and can do transfers or whatever. And there's a few more of these, and I can't remember all of them off the top of my head, and I haven't been writing them down over the couple months when I've been noticing them. But I know there's at least a couple more where you think about, oh, here's a way to look at solving a problem. And anyway, the point is, once you've identified these, I started to wonder if the way you test them isn't based on which one of these they are, right? So if I look at a problem in its systems and interfaces, the way I want to test that is probably very different than the kind of way I want to test a data conversion problem. Ratchet Freak asks, oop, are you asking if I forgot to put object-oriented programming into this? Because as I said, this isn't about methodologies so much as it's a different thing. It's what I'm talking about is orthogonal to oop. I don't know if you caught that. Okay, so once you've identified which of these kinds of problems you have, it makes it a little easier, or at least which of these kinds of solutions you have, because probably some problems can be looked at in multiple of these lenses, right? And so once you do, you go, okay, here's how I want to structure the solution. So like a data conversion problem is the kind of problem I end up solving all the time. I look at something and go, okay, I've got UTF-8 coming in, I want some kind of standardized output that I can then interpret into a buffer layout, which is kind of how the 4coder engine stuff is supposed to work. So what I end up doing a lot for my solutions to data conversion problems is I want to have, okay, I have this data stream coming in. For flexibility, I don't want to have to read the whole data at once, so I'll let the user pass in chunks at a time, and then I'll output chunks at a time, depending on how big of an output chunk they gave me. And so I end up with a solution template that looks very much like you have an in chunk and an in size, an out chunk and an out size, and some state, and then you want to keep on going until you've finished, right? And I've developed a method for testing that seems to work pretty well for me, which is that first you work on it for a brief period of time without testing it. Once you have something, you then make another version of it and you test them against each other. And that sounds weird, but the point is, if you do it in two different ways, like if I do one that reads 1 byte at a time and another one that takes in a whole chunk, the one that reads 1 byte at a time is probably correct, and then I test the chunked version versus the byte by byte version, make sure they're correct. Once I'm happy with that, I can eliminate the byte by byte version and then just test the data conversion against itself by using different input chunk sizes and output chunk sizes in different combinations and making sure that the outputs are always the same once you get the whole array. Because very often what will happen in these kinds of problems is if you chunk it at a different level, you'll expose a different bug, and then you'll have, okay, there's a mismatch, and then you have to go investigate which one of the two is wrong and why is it wrong. You don't necessarily know which, but once the test is just supposed to identify for you that there's a problem, in my opinion, right? Similarly, with this one, right? I have just noticed this one recently, so I haven't actually tested it, but I also haven't had many bugs in this land, so maybe, I don't know. I'll have to think about what to do with that one as time goes on. But with systems and interfaces, the way I tend to want to test things looks very different. I don't want to just run the thing and get results. That's when you want to do what they call a unit test, which means more like you separate this thing off and you simulate the rest of the world that it's supposed to live in. Or at least this is the way object-oriented people always talk about it. But it seems to me like if you have like a controller input or something that you want to test, you can't test that without the actual system, right? And so I can't test controller input without a controller. But once you accept that, okay, this is a systems interfaces kinds of thing, then what you can do is at least make a very simple checklist like, okay, it needs to be interactive, but once we accept that, we can just do the couple of things we need to get, and those layers need to be as simple as possible so that we can just communicate what needs to happen across the barrier, and that's it. There's also like now that I think about it, another thing about it, I can't remember. I know that there's at least one missing thing here, and I think that I wish I could remember it. But there's also this type of testing that we discussed about before we started, which was the integration testing, which is the idea of testing the whole program at once. And the thing about that I'm not totally clear on, that maybe I should find a way to fit in here, but the thing I'm not totally clear about on that is you run into a little bit of a problem where it's hard to define success and failure. One easy thing you could do is just like, okay, we're going to try and run the whole program, and we're going to generate lots and lots of input very quickly, randomly, and as long as it doesn't crash, that's a pass. And that's nice, especially if you leave asserts in, because then you're not hitting any of your asserts. Okay, so a couple things from the chat here. So, as if Gartner clarifies that an integration test is about testing multiple parts at once, not the whole program. And that's maybe helps, but so if you combine a couple of libraries, right, you could imagine there being a thing where, okay, the way these libraries are supposed to work is that they come together in this way, but we were wrong about how exactly they come together, and so the data that this outputs puts a null terminator in between each string, and this one doesn't, so we caught a bug in the sort of the formats between these two things that we need to do a conversion layer between them for it to work. But if there's a certain, you run into problems with testing where you're producing more code, and if your integration test has that bug, that doesn't necessarily mean you know how to translate that to the way that the same thing works in your actual program. Like you can identify a problem and fix it, but usually I don't see a test as being particularly useful unless it can stay there for a long time and test every time you change something that it still works. If I'm changing a portion of my program that glues two libraries together, how does my integration test check that the program still glues them together correctly? So let's see. Other than that, we have Glog78 asks, what can an editor / IDE help in terms of testing? So the editor itself doesn't help that much. I'll show you guys my testing framework and the way my editor helps me with it, but I don't think it's helping me like extraordinarily much. It's just a little bit of help. We're just discussing it because it came up because I mentioned it. Not really to do with 4coder in particular. Let's see. Okay, so let's see. Let's get off of testing because I think I've said everything I can say intelligently off the top of my head, or even semi-intelligently. Um, Probably not that clever yet. There's more to the idea I've got in particular, but maybe I'd have to show you guys my the framework I use to explain any more than that. Um, so I'm gonna check that off and say let's look at the test framework in a little bit. Um, so Ginger Bill has asked, how is MacDev going, which is one of the things on the discussion list. So MacDev is going all right. So far, I've got most of the things I have to do in Objective-C almost done. Um, and once I'm done with the Objective-C part, I'm hoping that most of the Linux code I can split the basically, since Mac uses Unix for a lot of things, I'm hoping that I can just split off the Unix shared portion of the platform layer and then have like, oh, here's the Linux stuff for opening a window, getting input, getting clipboard stuff. Here's the Mac version and Objective-C that does those things, and then they both have a Unix portion on top that works more or less the same way. About my thoughts though on Mac. So Mac porting has turned out to be a little easier than I expected. I mean, Objective-C was kind of a nasty hump to get over. Like, it's weird, really weird syntax for what's basically even worse version of a C++ class. Like, it does pretty much the same things. It's got methods, it's got members, and you can subclass a parent and override things and whatnot. Um, so all of that has turned out to be annoying, but once you kind of get used to, and it's also got a crazy syntax, but once you get used to all that, I found that, and also like the Mac API has, so my finding on the Mac API is that it's got like an upside and a downside that was kind of weird. Like I was going in expecting it to just be out and out worse than any other platform, but now that I've worked with it a bit, my feeling is more like it hit a really weird combination of improvements versus Windows and Linux and regressions versus Windows and Linux. So, for instance, in Mac, in the Mac, like in Cocoa or whatever, however you pronounce that API, uh, you you get information back that's like contains everything you want it to contain. So if I get a key event message, I can ask, okay, what's the key code? What's the character that got pressed? What's the character that got pressed without caps lock? What's the character that got pressed without modifiers? At least I think the without caps lock one is available. Maybe it's not. Maybe I made that up. But you can ask what the character was pressed without modifiers, and so on, right? So that's nice. And neither of the other platforms really made keyboard input quite that easy. For like Windows in particular, I had to do some hacks to like get it to tell me what the key would have been without the modifiers pressed, which is information I kind of need because I'm managing the modifiers myself. Whereas because Windows can't just tell you, oh, this key got pressed with these modifiers down, because if Control is down, it'll tell you a different key. It'll lie to you and not give you. It refuses to tell you what key got pressed. With Mac, they like give you the information you need. You actually get the data you want. And the downside though with Mac is that they have just the most obtuse API. Like it's so far away from the way I want to program my platform layer that it kind of like cancels it out. I was going in expecting like, oh, this Objective-C nonsense, it's going to be the worst, and the only thing that makes it not the worst is that they also like they give you the information you need to do the job easily. It's just the API is all messed up. Like you can't do some of the things you want to do, like controlling the order in which you handle these events and those. They come to you as callbacks. You lose a bunch of control over the order things come in. You just kind of are hoping that they happen in an order that makes sense, or you're like using you're using a like for instance, let me put this another way. In the Windows and Linux platform layer, I can just say, all right, handle my keyboard inputs, mess with them a little bit. All right, now run the app update step and render the window, okay, and make sure the frame timing is working, okay, good, and then go back to the top and wait for the next event. With Mac, it doesn't. With the Cocoa platform, it doesn't seem that you can specify that. Like you specify callbacks to when this event happens, when a key down event happens, I want to do this. And now it's like, okay, do you guarantee that key down events happen before or after a frame, and before and after the render? Like, when does what happens during repaint? When does repaint happen? Does it happen between these or after or what? You don't know. You just can't know because you're not in control of that, and that's like frustrating. So all of Mac, unlike the other platforms where you have a main loop and you just pull for events, with the Mac version, I have two options. I could either make the main thread sit there and do callbacks and then put them on a queue and have a secondary main thread in the C code that looks like a main loop and controls things the right way. Or I can do what I'm probably going to do, which is that I just, in the Mac layer, you have like 3 or 4 entry points for initialize, update a frame, handle input events, right? So Keyboard Caleb was asking for a specific example of a key on Windows, and what I mean by that is if you hold, like, if you go in and make a layer that takes in WMChar and you hit Control G, you won't get a G character, right? If you Control H, you won't get an H character. You get some other thing. And if you hit Control Shift G, you'll get the same thing if you hit Control G and stuff like this. You can't deduce from what you get what was actually done unless you hack it and tell it that Control wasn't being pressed. So that's what I have to say about Mac, really. Not too much to it, except that I think the Cocoa part is done, or will be very soon, and I'll be able to hopefully split up the Unix portion of Linux so that I have Unix plus Linux and Unix plus Cocoa platforms, basically, and then it'll almost be done. Fingers crossed. Probably a month or two, though, since I only do that a couple hours whenever I'm feeling up to it, because it's not a priority. So I see some more talk about tests, and I'm going to catch up on that. So yeah, Ratchet Freak, probably tongue-in-cheek, made the comment that the patrons are the QA team, and that's kind of true. It's unfortunate, and I don't really find that like acceptable. I don't want my users to be testing things for me and reporting bugs. Like, I get that there's going to be bugs and they're going to report it. I'm trying to make their lives better, so I need to catch a lot of that myself, which is what Team R&B seems to be saying. Yeah, so the way things go right now is I make a build, I install it on my own machine and use it for 3 or 4 days, and then I set aside 1 day to fix any small bugs that I have. If there were big bugs, I push it a week right? I push it a week or two. But if there's like small bugs like, oh, the way the view jumps now is wrong, we need to go fix that, right? I set aside one day to like fix those things that are kind of trivial, and then I release the build. And for the most part, that does an all right job of making sure that I haven't totally broken anything, but it still leaves a lot of like, I put out a build and then I get 5 emails from 3 different people about new problems they've got, and then a post shows up on the forums a week later saying, "Hell, I finally got around to trying the new build, and this is broken." And like the bug reports trickle in, and it's hard to keep track of all of them and stuff. It's a bit messy, and it's not great. That's the way things are going. I'm trying to make a better system. Or at least a system that cuts down on that, because fixing bug reports that I should have caught right away costs a lot of time right now, I think. Let's see. So let's see. Now, Glog78 and Team R&B are still talking about testing, so let me catch up on the rest of this. Continuous built-in tests. Team R&B, were you asking if I know how to test or what to test? I mean, you could give me your opinion on that. I don't, or your thoughts. If you have like information on, the first thing I said when we first started was that I was complaining that there isn't a particularly good formal understanding of some of this stuff. That I think, like, this is maybe my attempt at saying, couldn't we do some kind of classification of the types of problems you need to test, and talk about the methodology of writing instead of talking about the kinds of tests in terms of the goal of the test, which is unit tests, where the goal is to make sure that this unit works correctly, or integration tests, where the goal is to make sure that these things combine together correctly, or so on and so on. Or regression tests, where the goal is to make sure that this bug doesn't happen again. Instead, turn around on its head and say the kind of test you use is based on the kind of problem you have. And that it kind of ports its way across all variations of this type of problem. So, does this problem fit into this classification of problems? Then this is the testing paradigm that solves that. I imagine that that's probably a useful way of looking at things. And once you've done, like, for instance, the data conversion one, since I test that kind of stuff all the time, I'm building up to the point where soon I'm going to have, like, literal regression testing, where I'll have well, you'll see my testing framework in a minute. Let's see if I can catch up on the rest of this. So yeah, Log78 is basically describing what he understands about the sort of the way handmade programmers tend to set things up, and I think he's mostly right. We do kind of an old style dev cycle where you write some code, you build it, you test it, and you debug it. I mean, I'm familiar with some approaches where you try to like cut down on this, like the separation of those cycles so that they happen more quickly, but I'm not sure how you're thinking of them in terms of being completely separable. I mean, are you thinking of like yeah, I guess I don't know exactly what you're thinking of as an alternative to testing the code after you've written it. So I'd be interested to know what you mean. Hi, Slayer Darth. Yeah, this is in C++. So, I see. So Glog78 is talking about kind of what I'm actually doing, which is it's not perpetual integration or perpetual testing or whatever it's called, but I am building towards a thing where you have F1 is my build button, F2 through F4 do other things like F4 builds the x86 version, F3 builds the site, or no, F2 builds the site, F3 builds the string library, and now I'm building a test system, and F5 is run the test system. And basically the plan is you can hit F1 a couple of times because I don't want to spend time running tests when I'm not compiling yet and when I'm not even done building a system. But then I can hit F5 and go, okay, run the test again and get results back, and okay, hit the test again and get results back, and then keep going. This drunk Dane, I didn't ignore you. I even read one of your quotes. I read, oh wait, no I didn't. That wasn't you. Yep, I am ignoring you. I am. Sorry about that. I thought I read one of your quotes earlier, but I was mistaken about who said that. Let's see, I'll go read one of them now. Let's see. This drunk Dane wants to know, how is multi-thin cursor dev going? It's not yet. That's gonna be in 4.1x. Maybe not 4.10, but probably pretty soon after. The basis, the fundamental pieces I need for that kind of thing will be in 4.1x. Slayer Darth asks, which version of Windows is this? It's Windows 7. I turn Arrow off because it messes up a bunch of stuff, and I don't like it. So Glog is explaining to me about like a build server test system where you push to a build server, it builds and sends back a test suite. A couple reasons I'm not doing that. First of all, I don't really have that set up yet. Like over time, I've got a new machines now because I'm going to start cross-compiling more often. Cuber Caleb, I'm going to do multi-cursor like Sublime and like Visual Studio. I'm going to have different options available. But yeah, I also haven't gotten to the point where I totally need one yet. I kind of am getting to the point where I should get a build server set up. I'm thinking about reversing that since I kind of work. I don't work like in a distributed situation with lots and lots of people. I'm kind of the one person who has to be able to build everywhere and the one person who has to test everywhere. So when I had like Insofar come in and do a lot of work on Linux, when he came in and did stuff on Linux, he would work on stuff, but it wasn't really his job to build things in a package and release or anything like that. So I'm the only person who needs to do that. So one thought I've had is I don't feel like setting up a build server per se, but I've got the computers I want to cross-compile to. So what I might do is make a shim application that actually makes my computer the server, and they're all the build clients, and whenever I want to do a cross-compilation, it just sends to them a message that says, hey, pull from the Git repository, run a build, and then send back any errors you get to me. Then I can like take computers online and offline because they're clients, right? And my computer is the server. So I'm gonna probably set something up like that later on. But right now I'm still only really building on 3 computers, so I don't mind when a build day comes making sure it works on each one, like making sure it compiles on each one and then finishing. But I'll show you the testing suite that I've been working on because I got really sick of not being able to do the testing the way it should be done. Oh, shoot. I'm on the wrong branch. Yeah, the testing suite is a feature of the new branch. Oops. So Glog, as what was it? As if Gartner pointed out, I probably don't have a strong, like a large enough test load right now to want to test on each client individually. Maybe I would get to the point where I'm doing that, where each build client is running the tests independently. I mean, it wouldn't be too hard to just actually, once the build system works, have that as part of the script. I'll show you why. For my system, I've been pushing towards getting testing to look a lot like compiling, but just for a different target. And the way I did that, let me pull up tests, is I've got this And this will also answer a question for, who was it? Team R&B, who is saying he doesn't know much about C++ testing suites. I don't either. I don't think many people, like, most of the time people like to do that in sort of controlled languages where you can, like, handle crashes and whatnot. And so, like, it's C# and Java that kind of do a lot of the really really test heavy stuff. So let me show you the thing I've got set up so far, and how I think about probably um, testing in C a little bit, getting towards actually having a test suite. So let me pull up my translation test. So this is the test I started writing today. The first thing I did today was set up the very basics of the new testing system, and then started working on a new translation system, which is not done yet, so I can't actually I can't even compile this test, I don't think. But I'm going to finish it probably by the end of the day. But the way it works is I basically have each test as a different separate file. So this is testtranslation.cpp. And each of those separate files has a main function, which has a signature that matches like your standard int main, right? Right, so this is the actual signature of the function, and this is actually a macro that allows me to change its name from the compilation line. So I'll go over that first. The first thing that I do is when I build it, I either provide a test name or I don't. If I provide a test name, then the name of that function is whatever that test name was. Otherwise, I just make that the main function, right? So I can compile a test as a thing that runs by itself. If I want to, like, just run a test program, I can run a compilation. It's also kind of like a bootstrapping thing. Like, eventually, probably I always run from the larger framework that runs multiple tests, and then I just have options to run one test if that's what I really want to do. But sort of to get things started, I don't want to have to build the whole test suite system when I've only got one test to use so far. So I'll wait till I have 2 or 3 tests, and then I'll actually start using this more. But for the bootstrapping purposes, this is currently being replaced with a main function. Then I just, at the beginning of each test, your test is basically, I think of it as a separate program, right? And so this is the main function, and it starts with test begin. It ends with test end. And those are defined right here. And all they basically do is test begin sets a long jump environment right here. If you're not familiar with that, that's a C thing. You can just include set jump, and then you make a jump buffer, right? And I just have that defined globally. And then test begin sets it. And what happens is when I set that, it returns 0, and so it doesn't do this goto. But then I redefine my asserts so that any assert that I hit saves an assert message and then long jumps back to that environment there. And this 1 here says return a 1 now. So it then long jumps back to this call, and when it returns the second time, it's a 1, which then triggers it to go to the end of the test. That end of test is included right here in the test end macro, and then it calls a finishing function and returns whether or not the test failed. And things like, so the assert, for instance, sets the test failed. Oh wait, no. So the finishing function here prints out the assert if it happened, and sets the fail flag to be true or false, right? So if it returns false, that was a success. If it turns true, it was a fail, right? Kind of standard way for a main function to work. So then, the other sort of fancy pants thing that I do here is I take advantage of the way 4coder jump locations work, which is basically any line of code in a read-only buffer that looks like a file name colon, a line number colon, that's a jump location. So when I set my assert message, what I actually set is the contents of the assert that went wrong, and then I include that with a file name and a line string, right? And all that gets put together into one line that looks like the name of the file where the assert happened, the line number, and then the assert message, right? So that's the plan, and then it of course does the long jump stuff and exits gracefully. So the only thing that can go wrong is if it crashes for reasons other than an assert. And in my opinion, with good C style, you should be asserting frequently enough that that almost never happens, right? Like, there shouldn't be a code path that could read from 0 that doesn't first assert, or there shouldn't be a code path that can dereference a null pointer that doesn't first assert that that's not a null pointer, in my opinion. And a part of the reason for that is so that things like this can work, but it's about, if you don't have that assert there, it means you didn't recognize that this was a potential problem, which is not good. Like, you should recognize where the potential problems are and label them with the assert, and then that gives you all kinds of flexibility, because if you want your testing system to work this way, but then you could turn this into an error logging system for the build releases that log the assert that happened so that your user can send that to you and stuff like that. And I didn't really understand that when I first built 4coder, but it's sort of the philosophy I'm going with now, which is that all of your crashes should ideally be asserts, because then you have the flexibility to handle those crashes however you want when they happen. The only thing I wouldn't do is I wouldn't go so far as to say, like, oh, let's just do exceptions, basically, where the goal is whenever an assert happens, we recover from it. It's not, the goal isn't really recovery, it's just to record that and gracefully exit right away. So that's basically the plan, right? And is there anything else about this that's interesting? I don't think so. So basically what happens is when I run my script, my test script, it builds my tests, runs them, and then as they run, any errors that happen get reported in such a way that I can jump straight to the assert that triggered them. And the nice thing about that is it also, because I'm redefining my typical assert, it also works not only on top level stuff. Because I saw Cuber Caleb mentioning, like, oh, a good test is just to run a couple things and assert that the results are good. Well, I take that a step farther and say I assert that the results are good here at the bottom, but I also will catch any asserts that happen during the execution, because all of the asserts get translated in this way to this long jump thing. So that's basically my testing framework so far. The slightly smarter one will, like I said, set the test name for multiple tests and then run all of them. And then you can get a list of, like, oh, these are the tests that are failing, and you can like make metrics and stuff, which might be nice. I don't know. That might be too far for my particular use, but you could in theory be like, oh, this test seems to fail all the time, maybe break it up into multiple tests so that you can get finer grained information. And then the other thing that I want is sort of an automation of a few specific testing types. So this is the general framework that I'm using. So hopefully that answers for, I think it was Team R&B, how a test suite kind of looks in C. If you want it to, like, sort of have the property where you can run something and see the result and then handle it gracefully, not recover from it. That's what exception mindset is about, and that doesn't really work. But you don't have to recover from the error. You just quit right away after the error. You just don't crash, right? You turn your crashes into assert messages. Okay, so that's the basic idea. The other thing I want to do, and I think someone was mentioning this too, is I want to have some automated ways to express things like, oh, this is version 4.1.1 of 4coder. I have already run this test for version 4.1.0, and I've saved the outputs from some of the, like, regression test style things. So what the new test should do is 4.1.1 should look and go, okay, first I do some cross API checks where I say, hey, does this version of the API and this version of the API that entered the API in slightly different ways, like this does byte-by-byte translation, for instance, right? This does byte-by-byte translation, and this does chunks level translation. Do they agree with each other? Because if they don't, then there's a bug in one or the other of them, or both. Any Mouse says that the phrase "turn your crashes into assertions" sounds like a daily affirmation. Maybe it is. I don't know. I don't think about it too often. Just whenever I mess with my well, basically, whenever I'm asking myself, should I turn this into an assert, the question is there a reasonable way to believe that this could crash before hitting an assert if I don't? Okay, so as F. Gardner brings up an interesting point, which I'm going to deal with real quick. But before I get to that, the other thing I was saying I want to be able to do is automate the idea of here's a version, here's the previous version, and test the results of this like data conversion on both versions and make sure they're equal. And then that needs to be have a little bit of smarts, because sometimes your definition changes and you go, I'm appending an end of file token now, so they're not supposed to be equal. So what you need to be able to do is say, hey, don't run this for this version, right? And then turn that back off and somehow have a way to like automate that process. So that's something I'm going to do kind of over time now that I have a proper test framework in place that I can build up. But to deal with this other thing, as if Gardner says, it may be useful to jump to the test code instead of or in addition to the failed assert. Sometimes you have bugs in tests and you should verify that the test is correct before you start investigating potential real bugs. Yeah, so as if Gardner raises a couple of points. First of all, if an assert happens inside of real code, that doesn't necessarily mean there's a bug in the real code. There could be a bug in the test code, and that happens all the time. It could also be that the test code was correct, but then you changed the internal code in such a way that it broke the test code. Like you changed your definition, and the test code is now if you change your definition of what, like, oh, this call used to say you couldn't pass in a null, but it does, and I have a thing here that passes in a null, and then it returns error, but it's actually not like what's supposed to happen. Now the code, what it's supposed to do is the code passes in a null, and it returns like the result of this as if it was an empty string, and so the test is no longer correct. That kind of thing, you have to decide, when I do this, am I taking a bigger hit by keeping the test correct, or am I taking a bigger hit by the bugs? Right, and I think a mistake that some people will make when they get too far into tests is thinking that like keeping the test around, like somehow the test has to be correct. So either the changing the definitions has to be disallowed, or the time that it takes to rewrite these tests should always be correct. Is always preferred to the time it takes to catch a bug in a more general way. So I am particularly interested in how you structure tests so that you get information right away that is like, oh, you must have changed your definition here because of what's happening, or something like that. Like the languages we have right now don't really give us a good way to mark up code for meta reasons like that. But you could imagine a situation where it used to be that you weren't supposed to pass null, and now you can, and so you've marked up the code in such a way that's like maybe even custom, maybe like a JAI thing where you have a comment on the code, like a note, and then the test will go, hey, the notes have changed on this thing, so you need to reconsider this, rather than just be like, here's an error, and you forgetting what changed. Ginger Bill says he's trying to do something like that in Odin. Yeah. Yeah, there's definitely a lot of progress I think you could make with better languages, or something like that. So that's basically what I've got to do on testing. Now there was something else I wanted to address. That's something that came up maybe? Oh right, the idea of jumping to the test code. That's probably something that's a good idea to have like a second line after a failed, like after an assert that is in a test, because I always know what test. I always know the name of the test, which means I should know the name of the file name for the test, which means I should be able to say something like, oh, this assert happened, which was running during the test at this file. Ideally, here's an idea for Ginger Bill. It would be spec'd into the language that you can do something like inspect a call stack. At least like have a debug feature that's like, hey, if you're building without optimizations, you can inspect the code stack programmatically in a well-defined way that's portable. Because then what you could do is walk the stack back up and go, I was in this function at this line, so put that in the assert that the calling test was this test. Okay, so that's it with testing. Enough of that. What have I changed? Whoops. Don't do that. Okay, so I've lost my discussion list now, but is Captain Kraft still around? Because I know I originally said I would chat with him about something, but we went on for a while about a bunch of other things. I'll see if I can, because if he's around, or if anyone else, I know Keeper Caleb might also be interested in my string thing, because he wanted to talk about Unicode. Okay, so Captain Kraft is still here. I'm gonna dive into strings real quick. So, my string library, first of all, this isn't necessarily meant to be like, oh, you should use my string library. You can if you want. I'm not saying you can't. It says right there, public domain, use it however you want. You can use it if you want. You might want to write your own to do a couple things differently, or I don't know, whatever you want. I don't care how you use this information. But one thing about this is I've been working on it for so long that it is going to be a little hard for you to get all of the things I list now, but I'm going to try to start with the most salient details and then work backwards. So so you can get the gist of this, because there's a lot that has gone into it over time. So the first thing about this was I want it to work in basically a way that's very compatible with C strings, because I deal with a lot of APIs like the Windows API, the Linux API that expect and return C strings, and I'd love to say no, my whole system is all length and it's all strings with lengths, but eventually you have to convert to C string. And you also have the problem that any literals you define are C strings until you give them a length anyway. So their C strings are around, and I figure I just need to accept that this isn't going to be like a magical string type that is exactly what you would want in the best string supporting language, but is the closest thing to a flexible version of a C string that you could get, right? And it should have a length specification built in because that's better, but conversion should also be trivial. So that's sort of the basic idea. And so my string struct is very basic. It's the C string pointer, which may or may not actually be null terminated, and then a size and memory size, or like size and max, whatever you ever want to call that there. Now, unlike, say, the standard library string or any other, the way most string libraries work, the string system does not do any allocations. It does not ever provide memory for your strings. The user is completely responsible for passing in the memory that becomes a string. And this completely changes the way you think about your strings from then on, because now if I want to do something like foo, then say you have like a good string system, you would maybe expect that you could do something like foo equals file name plus colon plus line number plus colon plus error message, right? Plus new line, right? Or maybe you think plus isn't a good idea because plus is for adding numbers together, so you wish like your language had an concatenation operator, which I think is a good idea for any language that supports strings. Then you do something like that. But in C, that's not going to happen. So the closest thing I can really imagine doing is saying we were going to do something like start with a string, and we'll just assume that that's empty. So let's maybe like initialize it to 0 to be an empty string, and then what you do is you say something like append onto my string the file name, append onto my string the colon, and so on. So building strings up like this is about as close to being as good as it can be in C. You could maybe use a variable arguments function, but I was a little bit concerned about performance when I built my string handler, because it is a text editor that I built it for initially, which is just a gigantic string handler, and so I end up doing string operations all the time, and I figured I need this to be fast. So it's pretty verbose, but it expresses the same basic concept, right? And then what you can do is say, all right, what if my file names are null terminated strings, like C strings versus string structs? What happens? Well, in C, what happens is append has two versions. Appending to S is always the first thing that happens, right? Well, it's not always, but in this case, we're always appending to a string. And then, is it a string or a C string? String, C string, string, C string, right? And of course, this also fixes a problem in C where if you have two C strings, it like has this problem where they're not in the right memory location, so you can't combine them either. With this kind of string, you know how much space you have, right? It's encoded right here, so you can perpetually fill out more of it until that's too big, right? So unless this runs out of space, you can usually build these things up. Now, when you're doing something like this, where you're just making like a local string that is the concatenation of a bunch of things, the way you provide the memory, or at least the way I provide the memory, is I just go, okay, the file name's probably not bigger than this many bytes. There's 1, 2, 3, 4. That's probably about 5 more bytes. So 100. Let's give it 500 bytes. All right. So I just call this my string space, or something like that, right? And I go, oh, let's give it 500 bytes. And then I have a call called make fixed width, or it's not a call, it's actually a macro. Make fixed width string, and you pass in the memory that's fixed width, right? So you pass in your stack memory, and now you've locally allocated on the stack a string. You provided the memory, it's stack memory in this case, and then you filled it out, right? And this is pretty nice. Now, like I said, this needs to be able to convert to C string very easily, so I also have a call that's just like terminate with null. And now, call with C string, You just go string.string, and there you go, right? So that's pretty nice. The only other thing that comes up is this is a locally sort of allocated piece of memory. You do have to manage all of the memory for the string system yourself, so if you get to a point where you need like persistent strings across multiple frames, you need some kind of allocation scheme. That turns out not to be crazy either. Like you can just, if you like for instance are always going to need the strings once you allocate them, you just push them onto a stack. Worst case, you have to allocate sort of a small strings heap, but hopefully not, right? And even the other point I'd like to make about that is if you go the other way around, where you say, no, I want my string library to handle all the memory, the problem with that is you then have to pick one string allocation method and stick to it, or you have to make like a couple of options. This doesn't have those problems because now it's totally flexible to whatever allocation scheme you need, which often I have found across one application. I want to use strings. I want to use the same string interface in lots and lots of places, but those strings sometimes need to be allocated in really fancy ways, and sometimes they can be allocated on the stack. Sometimes I don't need to actually allocate my strings at all because I already have the text somewhere, and I'm just putting the string struct on top of it to get a couple of the features out of the string interface. So Glog78 has a good question. What about buffer overflows? It is a problem, and you have to work with that. So for instance, this one here, you definitely don't want to let this overwrite the end, right? So the string library has this memory size, and it never ever ever writes past the end of that, right? It knows how big the memory is. It can grow the size up to, but not including memory size. So what happens if this is big enough that this right here is the 501st byte and it can't fit in, right? Or what if this null terminate with null doesn't let me put a null terminator on? Well, they work a little bit differently, but handling that is important because having stack memory corruption is like the worst bug you can have. So one of the trade-offs this makes is, in order to have this very easy way of on the stack allocating a string, the other thing we have to accept is, okay, if we try to write too much to that string, we just have to not write it. So if I try to append this new line character on there, it'll go, okay, not going to do that, and just fail, right? And we can go and look at that, append sc, and you can see that it returns a boolean, a b32for-tech is the name on this library, but these types both return booleans, and so do all the copies. Well, actually, no. There are versions of copies for C strings, right? So if I want to copy to a C string, I try to avoid that. As you can see, I've named it fast unsafe because it doesn't do any memory length checks beforehand, and then it returns the size afterwards. So this is actually totally unsafe, and you only use that when you like know for sure that you need to use a C string copy, and you know you have got the right amount of memory for it. But that usually is not the one you use. So copying to C strings doesn't happen very often in this system. But it doesn't need to happen very often either, because usually if you're copying to a C string, it means you're building a C string. The preferable way to build a C string is actually to build one of these strings and then just pull the C string out at the end. All right. Well, thanks for hanging out, Captain Craft. Sorry I didn't get to all of it. I'll upload the stream so you can catch the rest later. Yep. See ya. Now, Caleb raises another good point, which is, what about the null terminator? As I said, this works a little differently from this one, because this says refuse to write if there's not enough space. But the null terminator has to guarantee that there's always a null terminator, because if you pass something to a C string API that's expecting null termination, and that thing isn't null terminated, then you are going to run overflow a buffer anyway. So when you terminate with null, what it'll do is say, hey, is there space? Is there space between, like, is size less than memory size? Then great. Don't increment the size at all. Leave the size where it is, but just write a null terminator in there. If size is equal to memory size, it'll go, shoot. It'll decrement size by 1 and put a null terminator in there, right? So it does guarantee that you get a null terminator no matter what, so that you get C string safety. And sometimes what will happen there is you get a bug like, you know, this thing needed the last t on the .txt and now it can't find the file, and so it just ends up crashing later. But that usually is a crash that is less mysterious too, because again, reading and writing from memory addresses that are on the stack but aren't what you think they are is almost always the most frustrating kind of bug to hit. So this whole system, built on the convenience of being able to allocate memory however you want, including off the stack, does have to make the trade-off of saying we can't assume anything about the safety of going past this memory allocation in the string pointer here. Okay, so that's the basic idea, and with that struct in place and sort of these basic things like copy and append, you can also imagine a bunch of other helpful things like string equality. So I have a string equality for C string to C string to S string, I guess I'll call it, or S string to S string, or obviously C to S, but that's the same thing, right? That's, you just flip them. And then S string to S string. So each of those is implemented slightly differently, which is, you know, kind of a lot of work to set up the first time, because you're like, okay, we got to implement with 2 S strings, we check that their length is the same, and then iterate with 2 C strings, we're checking if we hit the null terminator at the same time. With one of each, we have like the iterator on the C string needs to go one past the end to see if there's a 0 there, and so on. Similarly, there's a bunch of other helpers like that. Comparing is basically matching with greater than or less than checks in there as well. Case insensitive checking, all that you can kind of build on top of, and it's not too hard to imagine how you build that on top of this. Hopefully it's not too hard for you to imagine. It's not that clever. Just never read past the end of size or memory size, depending on which one you're in. So, a couple other things, slightly more advanced topics here. Like I said, these are the C names of the functions. If you don't define f-string C before you include it, you also get the C++ names, which just overload them all to not have those types appended at the end, so you can use like append on each of these, even though they are probably all different types. And then the last thing, and the most advanced thing, is there's this concept that once you start using it, you realize, which is depending on where the memory comes from, you have to treat them differently. And so like a string like this, for instance, you treat it a little bit differently than a string that you allocate on your own heap system, or like on malloc or something. And that's also totally different from, say you've got a file and you're parsing it. Well, you can put a string. Let me make a new example for this one because it's a pretty big deal for like file parsing problems anyway. As you're parsing along, you can have a thing like you know, data equals load file, test file, whatever, right? And then what you do is you go, okay, let's say I want to start with a string that is the, you know, cleared to 0 string, and I've written code like this before, and it's a pretty nice way to iterate over these things. You then do get next word, for instance. You pass in the data, you pass in the string, and of course the data could just be a string now that I think about it, so let's call that a string. So there's the data, there's the string, and you say, give me the next word. And so what happens is, at each step there, it gets the next word with whatever delimiter rule you want. The whole line, maybe alphanumerics, white space delimited, right, white space delimited, whatever you want. And that's not built into the library just because I've only ever used it once or twice. For other purposes it might be more useful, and so it probably should be built into the library someday. But point is, this lets you iterate over each word in succession, and the way it does that is the string pointer inside the string struct moves along, right, and then you can do that plus the size to find out where's the end of this word? So whenever I pass this in, it goes, okay, well, let's see, the string struct right now is null, so set it on the first word of the file. And then after that it goes, hey, this is not null, so take wherever our string pointer is, add the size, and then iterating from there, find the next word, and then put that into the string struct and go. Now, once you get that struct back, you've kind of gotten a string for free, right? You didn't allocate it. You had to load the data for the file anyway, so you didn't allocate the string at all. You just have a pointer into the file data and a size member. Now, what happens with memory size in that case, right? What should happen? Well, you could imagine maybe memory size should be equal to size, because that's how big the memory is, but I decided that should actually be not the case. For things, you can also denote a special kind of string, like maybe a read-only string in a sense, which, although it's not technically read-only, you could write to it, and sometimes I do, but you just have to know, so read-only is not the right word. But the point is the memory size is set to 0. And the reason for setting the memory size to 0 is because there are certain calls in here that never reference memory size, and there are some that do. And by setting that to 0, you're basically saying this string should only work with things that don't refer to memory size. And the interesting thing is, the only ones that refer to memory size are the ones you never call in that situation. So for instance, find string, right? If you've got this line and then you want to find a string in it, well, that never has to refer to the string's memory size, so it's fine, right? You can find a string in that line of the file by just passing that string into your find string call here. On the other hand, if you want to append, let's say, to a string, well, that's treating it as a mutable string. It's now going to check the memory size and then go, oh, hey, this doesn't have any memory, you can't write to it. And so it'll prevent you from like editing the file as if the string you got from it was a separate copy, which it wasn't, right? If you wanted a separate copy, you have to make your own allocation and set the memory size accordingly. So that way you get sort of runtime checking of mutability correctness, right? Instead of like const checking, which is easy to cast away or hack around, and whatever, and ends up costing you lots of typing time. My finding is with consts in the compiler, I often get into fights with the compiler about like how far down my call stack I'm going to call something const that I really don't want to call const because I'm actually writing to a portion of the memory but not most of it, and that portion is like a special counter inside of a struct or something that's supposed to count how many times the thing got read, right? And so I never deal with const because I don't know, just doesn't make any sense for me to do that. But I have found that like in situations like this where the string comes from a file, usually you find that if you just keep in mind, okay, I'm not actually using this string as a in the way where I'm writing a C string out and I'm using the string as a structure to help me write it. I'm instead using this as a structure to help me read a string, but it's the same structure, so you can easily write a string with that struct and then pass that struct to a reading thing that reads the string back. So basically, I'll sum up, long story short, the idea is basically this struct that you use is basically a framework that you put on top, or like machinery you put on top of a C string, and then it either helps you write out a new C string or read an existing C string, right? So that's basically the idea. And by C string I don't mean null terminated string, I just mean an array of characters that you pass to it separately. Alright, so I saw the chat running for a while and I want to see what everyone was talking about. So Keyboard Caleb wanted to know what does copy partial do. Copy partial means, so basically there's two different ways you can copy. Copy checked means you check for the length, you check the length of the string before you copy to it, and if you can't successfully copy the whole thing, you don't copy anything. Copy partial says, hey look, just put as much of this onto the string struct as you can and then stop. Let's see. Yeah, okay, so CryZ92 asks, why don't you use C11 generics for this? I don't know anything about C11 or C11 generics. I'll look into it because I'm interested in a good generics programming thing, but I tend to end up regretting using anything that has the word generic in it. So I'm not optimistic that if I look at that C11 generics that I would be convinced I should put it in. But um, regardless, I don't want to put it in because it probably wouldn't compile as people have mentioned. So. All right, Ginger Bill, I'll send you an email when I'm done streaming about call stack inspection. I think when John first announced his language, I was like 3 or 4 years ago. I can't remember when that was. It was just a couple months before I started 4coder, so back in 2014. And like I said, I was not a very good programmer back then, so I thought I was super clever and had a bunch of great ideas. And I sent him a couple of emails, and then over the course of a few months, I realized how much better, like how worse I was than I thought I was. And I stopped trying to give him ideas because, for the most part, he knew way more of what he was doing than anything I had. Like, I was mostly like, hey, what about things like this? Would you do it this way or that way? And are you going to solve this problem? And I'd like to see that problem solved. What do you think? And so on. And then over time, I realized, like, oh, he's thinking on a completely different level than me. And I basically stopped giving him ideas. But in that time, one of the ideas I did offer was I thought stack frames should be somewhat more interchangeable with something like a struct. Maybe not totally a struct, but I thought it'd be very nice if you could say something like, oh, give me a struct that matches the layout of this call of this particular function, right? Like, here's a function. Treat the layout of this function as a set of structs and unions with members in them, and give me, like, even with all the padding that you're going to put in for, like, registers and stuff, leave the padding in, but give me a specialized struct that just represents the data layout of this frame so that I can inspect it myself. And didn't hear back on that one, but I thought it was cool. I still think that's cool. Although I do get that, like, you couldn't really keep that in a optimized build because you would. Let me go vote for GoTo real quick. Oop. I didn't know there was going to be a GoTo option. Oh, I'm not going to vote for GoTo in that context. I'm voting for the for loop. There we go. Okay. Yeah, I always thought that inspecting that, like, you couldn't really keep that in an optimized build because, like, things go in registers and stuff, and so, like, a lot of the things you'd hope to be able to inspect wouldn't necessarily be there. You could, of course, say, like, oh, if you ever reference this this particular function's frame layout, then you keep it, like, in the expanded version, but otherwise you don't. You take the performance hit there. But I think even that's a bad idea. I think you would just want it to be like, hey, you're using optimizations, but you're also using this feature, and you can't do that. I don't know how you feel about the Ginger build, but I've always thought that in debug builds there should be more features than in release builds, because you should be able to, like, do crazy levels of inspection on things you can't normally do. Like when you build with debugging turned on, the language should have debug features in it. Is my thinking. So CryZ92 wants to know why I like the 4 version. So CryZ192 wants to know why I like the 4 version like this. Why I don't use a while loop. Whoops, where's my 4 code? There it is. Why I don't use a while loop. Why I do a for loop with the 2 semicolons. So let me give you a series of reasons going from least convincing to most convincing. Okay, so the first one's not meant to persuade you at all. It's just to point out that the number of characters I have to type for this is equivalent to if I had typed a while loop, because with a while loop you save these 2 semicolons and you gain 2 letters here. Okay, so that's thing one, is they're literally equivalent in every way. Except that thing two, I guess you could say you can't grep or search for while loops, but why, like, searching for loops doesn't make any sense anyways. Like, if you want to know how many while loops you have, that's kind of an arbitrary metric, I guess I would say. Like, it might be interesting to know how many loops you have, but then that's an argument for putting everything as a for. Okay, second thing, second real reason, not me randomly going off. The second thing that makes me think this makes sense is when I'm writing a while loop, I'm putting a condition here that says while do this thing, right? And it's often that the first time you write code, you don't know exactly how it's going to end up. So you write it, like, say I wrote this as a while loop, right? Then I write that, and then later I go, okay, well, I want to keep a counter like this, and then I'll just, at the end of each of these, I'll increment the count by 1. Okay, great. Well, I'd really like to change this to be something more like, or word count. I decided that what I really want to do is get the word count, and I get that from my data. And then what I do is, okay, so I guess as long as I'm less than the word count, right, and then I can get word from the data called at position count, right? Alright, so here's the thing. Now, I'm sure that this is eminently clear to you, having watched me do that, is I just transform this into literally everything a for loop would have given me, right? And I found that this was more likely to happen than I realized. Like, things that I thought would be a while loop over time evolved, and they got an increment, and then they switched to being initialized, tracked, and incremented the exact same way a for loop would, and then sometimes my for loops would also morph from checking that way to checking the way a while loop does, and there's kind of a fluidness between the two concepts. So to save me the time of having to rewrite this and go, what, this should really be a for loop now, change that to a while, add the semicolon there, let's see, add the semicolon there, or delete the semicolon there, right? It's just, that's not like too much typing, and obviously typing's never like that big of a deal. If you gotta type that out, then you gotta type it out, but I just figured, why bother? If I had started with for loop the whole time, then when I added the count, I would have put it right here, and when I added the get word count, I would have put it right here. It would have naturally evolved into a for loop. Okay, so that's my second reason, which is that over time code evolves, and the for loop can do everything, whereas the while loop can only do one thing, basically, right? Now here's my third reason, and this is specific to me. So it's not necessarily meant to be convincing to why everyone else should switch to while loops, but it's the reason, or switch to only using for loops, but it's the reason I initially decided to switch to only using for loops, because the thing I just listed is a side benefit that I knew I would get, and I decided to get it, along with this other problem, which is that was just a typing problem, but let's go back to what it looked like before I converted it slowly over time, over multiple iterations to this, right? Not that, to, well, yeah. So suppose we were back to this, right? Now suppose we get to the point where I decide I want to count, and I do that. Okay, so I'm not at the full for loop thing yet, because usually in a for loop you don't want your condition to mismatch. Like the standard idea of a for loop, these wouldn't be something that should mismatch. Like your count, initializer, and incrementer shouldn't be a different thing going on than the check. They could be, it's just odd, right? And I actually do sometimes mismatch those things because I always use for loops, but if you were doing things kind of the sort of standard, clean, obvious way that people tell other people to do, you wouldn't do that. You would use a while loop probably. Or you'd use a for loop and then do an if and break out or something like that. So the other problem I have is I found that very often I would write some code like, okay, well now what I actually want to do is, I want to do foo bar on the string with the context, right? And then I realized like later, like, oh well, what if we're in mode and we're in mode 1, then I want to do all of this, and otherwise, let's see, I want to do barfoo on the string in the context instead, right? And there we go. So what just happened there was I did the natural code transformation, which was to assume, okay, everything inside the body of this loop happens every step, and I want to say, okay, the work that's getting done at each step of the loop is no longer going to happen every time. It's only going to happen if we're in mode 1, but mode will sometimes be in mode 2 now, and so sometimes I'm going to call bar foo. So all the code that's in the loop now, and imagine there had been like lots of code, right? And maybe there was lots of code here too when we were done writing the new thing. I just sort of assume, sort of the natural thing for me to assume was to go, okay, well, grab the body of the loop, throw that inside of an if, and then else it, right? And of course that's wrong. What I really meant to do was to put the count right here, but the natural code transform has the incrementer, the natural layout of the code doesn't signify the incrementer as being in any way different from the rest of the body. So when I do a natural code transform, like grab everything in this body and throw it inside of an if, because I only do it some of the time, my mental model doesn't include the fact of, oh, also think about the counter and is it in the body or not, or whatever, right? And that's why I like for loops for myself, where I decided I kept getting this bug where I would do that crap. So how about I just always, if I have an increment, try to make it go there, because then it isn't a part of the body that you transform on. You do code transforms on. So this is something I would probably write like this, right? I would do a for loop, and I wouldn't put this right here yet, because like I said, the test, I want to signify that the test is a little bit different from this increment here, but I want things that are supposed to increment always to go up on the top, not down at the bottom. So yeah, that's why I decided to never write a while loop, because it would confuse my my brain when I tried to mutate the code over time. And yeah, the final reason, like the secret fourth reason, is that, of course, and I was going to get to this, but Ginger Bill said it before I remembered it. The secret fourth reason is if you're going to transition to Odin, which might be something you want to do, if you're me, you want to get in the habit of only using for loops anyway, because that's what Odin's going to do. Yeah, the only thing, and I do once in a while use a do while loop. It comes up. I don't love do while loops, because while they do put the condition where it logically makes sense in the flow, having the condition, it just is it's totally different from everything else in the sense that like you've got control flow like surrounding your block now, which makes it harder to parse. You also have this thing where like the scope is all messed up, I guess I would say. Like you can't use things declared in here, even though it comes after, which is a bit surprising, right? And you can't declare things here like you can in a for loop, so you can't do things like, you know, up here you can do like, I don't want to leak the variable count out to the rest of the scope anymore, so let's put it right there. And now I've kept my variable, my namespace a little bit cleaner. You can't do that with a do while loop and so on and so on, but you can't really match these semantics with a for loop very well, because it just doesn't have that option. But often my loops often start like this actually, and then I'll end up with a if break if I really don't feel like putting a do-while loop in. The do-while loop is usually just when I want to do something and the if break is confusing me at the end of the for loop. Yeah, the semantic meaning of do is something you can't really get from anything else. You can get it with a for loop where you do an if break at the end, but it's the for loop is a little bit tricky. Yeah, so Glog78 is pointing out some type of, like, I don't know, it would be layout problems or something. When you put conditions in your loops like this, he's pointing out you don't see them when the code is folded, which is true. I don't personally use code folding all that much, but if you are using code folding, these are concerns that I don't that I imagine factor into which loop you choose to use. Although arguably, it'd be nice if your IDE was just smarter, right? Because it could probably do something like find all of the flow control in here, breaks and continues and stuff, and then when you've got it folded, you could optionally say like, hey, show me like the conditions under which this thing breaks and continues as like maybe small notes when I like hover over it with a tooltip, or kind of like, you know, the new Microsoft Visual Studio like 2015 and above, or maybe 17, somewhere in there they started adding like that little like less than 1 millisecond thing as a little tiny text there, and you could do a lot more with virtual text than that. Ratchet Freak asks, is there custom folding in 4coder? And he includes hint hint because he knows the answer, I assume. There isn't any folding right now. 41x will get us a lot closer along the way of getting there, although it won't actually get us all the way there because I didn't think of that, but maybe I should. Cuber Caleb points out that the less than 1 millisecond thing is so useless, which is true because almost all lines of code execute in less than 1 millisecond, and you're also executing them as one step in a debugger. So it's like, does the timing of this step even make any sense as a thing to measure when it's sandwiched in between two debuggers, like stop points? It's not clearly relevant, even if the precision was good enough to be helpful. But the reason I bring that up is since they've got that like tiny virtual text already in there, what they really ought to be doing now is figuring out how to like use that to give you more information about what's in your for loop. Alright, so let's see what time it is. That's like 6 hours, or not 6 hours, that's 6:45, which means it's almost, we're going towards a 2-hour stream. But I think I'm all done for today. I see a hello Marble Blaster. I just wrapping up the stream, so I can't stay on the stream and chat. But I'll answer your question. No, I use C style C++ stuff for the most part. Alright, so thanks everybody for coming in and hanging out and chatting. I'll be around in a week or two for another 4coder Friday, and I'll see you guys later. Bye-bye. Oh, that's not the right window.